Great.
No.
Yes, we can see.
Great. Thank you. So, hello and a warm welcome to MDPI Resilience-Driven Approaches for Structural Investigation and Repair. My name is Laura and I will be your host. Thank you for taking the time to join us online today. We'll be starting shortly, so if anyone joins a little late, they can easily catch up with the discussion. This session is being recorded and the recording will be available on the webinar page afterwards. You will be able to find details about certificates and other information in the chat. I hope you enjoyed the presentations and find the discussions insightful and inspiring. Without further ado, let's get started. So this webinar is organized by MDPI, a pioneer in open access scholarly publishing, established in 1996 and headquartered in Basel, Switzerland with the first journal Molecules. Our mission is to promote open scientific exchange across all disciplines. Today's webinar is hosted by the journal Buildings. Buildings is an international peer-reviewed open access journal on building science, building engineering, and architecture published semi-monthly online by MDPI. Today's program will begin with opening remarks from our chair, Professor Tiago Miguel Ferreira. This will be followed by a presentation from Professor Humberto Varum on built heritage, risks, challenges, and possible paths for conservation and rehabilitation. After that, Professor Ilaria Venanzi will present us intelligent damage diagnostics and structural risk assessment for existing assets using structural health monitoring data. Professor Gibson Rocha Meira will give us a presentation on reinforcement corrosion in marine atmosphere zone, key aspects, modeling, and challenges. After all presentations are completed, we will hold a Q&A session. If you have questions, feel free to drop them in the Q&A box. We'll be sure to answer them right during the Q&A session. Now, I would like to introduce our webinar's chairs. Professor Tiago Miguel Ferreira is an assistant professor in the scientific area of structural mechanics and structures within the Department of Civil Engineering, Architecture and Environment at Instituto Superior Técnico, University of Lisbon, Portugal. And now, Professor Ferreira, I will hand the floor over to you and you can introduce the speakers who are joining us today. Thank you.
Thank you very much, Laura, for the introduction. So it's my great pleasure to be here today sharing this seminar. Thank you all for joining us. I'm very excited about this opportunity. So as Laura said, the title of this seminar is Resilience-Driven Approaches for Structural Investigation and Repair. And today with me, I have three very dear colleagues, Professor Humberto Varum, and I'm going to present them in the order of their presentations. Professor Humberto Varum is a full professor at Civil Engineering Department at the Faculty of Engineering of the University of Porto in Portugal. Thank you, Professor Humberto, for joining us and for sharing your amazing work on these topics. Then we are going to have Professor Ilaria Venanzi, who is an associate professor at the University of Perugia in Italy. Thank you. Also, Professor Ilaria, for being here today and for sharing your amazing work as well. And finally, we are going to finish with Professor Gibson Rocha Meira, who is a full professor at Federal Institute of Education, Science and Technology of Paraíba. Thank you, Professor Gibson, for being here with us today as well. So we are going to have, I guess, I did not see in advance, but I guess we are going to have a very interesting set of presentations touching on different topics. Professor Humberto is a world-leading expert on seismic performance of buildings, so I guess his presentation is going to touch on these topics. Then Professor Ilaria is as well a world-leading expert on structural monitoring, health monitoring. So it's a very trendy and important topic nowadays. And then Professor Gibson Rocha Meira is going to share his work, I believe, in corrosion of reinforced concrete structures and on the resilience of these structures in difficult environment, let's say this way. So just as a brief introduction, I would like to say a few words about what is the motto of this webinar. So we know that structural engineering in general is facing a lot of pressures nowadays for different reasons, but I will mention a few. So aging assets of of these structures, of course, climate-induced hazards, also the changing of construction practice, and importantly, the introduction of these new digital tools, which is completely changing our setting. So we know these challenges, they are creating, of course, practical difficulties, but they are also opening a lot of opportunities. And this seminar, I think I would like it to be more about these opportunities, identifying the issues and trying, to look ahead and see what we can gain from these challenges in terms of learning and also in terms of practice and what the future of structural engineering can be. So with that in mind, we are going to explore this idea of this resilience-oriented thinking, which is basically a way of examining our structures, but not only how the structures behave under these loads and deterioration, but also how we can investigate, how we can support decision-making, and how intervention strategies at the end of the day can be organized to produce safer and more adaptable systems. Okay, this is what we thought for this seminar, and as the share of this webinar, what I would like to be, and I would encourage everyone to think critically about what we are going to watch here, and also to discuss, to participate in this discussion. So we are going to have this, as Laura said, we are going to have these 3 presentations, and then we have a Q&A session in the end. And importantly, this seminar is also a kind of first event after a larger event that we are going to organize in July 2026, next year, also with the support of buildings of the journal. We are going to organize an international conference on building pathology and construction repair here at the University of Lisbon, Instituto Superior Técnico. And the conference is going to be about this. So it's a large scope conference about building pathology and rehabilitation, but we are going to try to put some emphasis on these challenges posed by climate change and new technologies. Okay, so in the end, I'm going to present a little bit more about the conference, but the abstract submissions are open now. And we invite everyone who is attending this webinar also to look at our website and participate in this conference, which I'm sure is going to be an amazing space to discuss these topics. So this was my brief presentation. So without further ado, I'm going to present again the first speaker, Professor Humberto Varum, who is going to present his talk about built heritage, risks, challenges, and possible path for conservation and rehabilitation. So Professor Humberto, thank you very much once again, and the floor is yours.
Thank you, Tiago. Please confirm me that you are seeing full screen mode. Wonderful. So I have to start addressing some thanks first to Laura Tocila and all the team that work from MDPI, in particular from the Buildings Journal, for all the professional organization of this event. I'm sure that the event in the next summer, SIMPAR in Lisbon, will also receive good strength from the support of the journal. So a big thanks to Tiago, our chairman, for all the work he's putting on the organization of the event, also today in the organization of this webinar. And of course, also I would like to address my compliments to the colleague speakers of this webinar, Professor Ilaria Benanzi and Professor Gibson Meira. So, and finally, and not less important, all the audience, I do hope that we all will gain from the seminars that we'll be listening today, and especially I do really hope that it can be a good appetizer for the larger discussions that we hope to have next summer in Lisbon during SIMPAR event. So as Tiago just referred, in fact, my talk will be centered on the built heritage. I will be densely speak about the risk, particularly on seismic risk, but not suggest challenges and possible paths. So in fact, as Tiago also proposed to us, I would like that all the problems, all the situations, the challenges, the threats that we consider that are affecting our heritage may enforce us to look for solutions, because we are sure that you have technology, you have knowledge, and so you just have to put the right knowledge in the right path in order to really do the conservation and intervention of heritage in the better manner as possible. So my intervention is centered generally in built heritage, but the main focus is on buildings. Also, I'd like to say that I will pass a set of messages. Some of them are eventually more oriented towards new buildings. Other ones are more oriented to older existing buildings. But so please feel free to disagree with some of my comments, with some of the provocations that I will leave in this seminar, hoping that these provocations may eventually help us to our discussions during the event during SIMPAR event in Lisbon next year. So allow me please to start referring that, in fact, if you look at this map that represents the distribution of the World Heritage that is recognized by UNESCO with universal value, you can see the distribution in the world is not uniform. In fact, we have in the old continent a strong concentration of this heritage. So this increased the responsibility of the continent, but also I'd like to highlight from this slide that, in fact, about 10% of the sites recognized by UNESCO are already registered in the list of heritage at risk. Among sources of risk, of course, earthquakes or other natural hazards, but something that should concern us is the problem of degradation and the lack of proper conservation. This is our responsibility, and we should put the focus of our international community in order to avoid the depreciation of this important heritage. For the case of Portugal, we are proud of a list of heritage, and among our heritage sites recognized by UNESCO, I detached here some examples. Among of them, please allow me to refer the historic city center of Porto, the city where I have the pleasure to work and to live. And I invite you to visit us. But coming down in this list of values associated to our heritage, we should consider that apart from the heritage recognized by UNESCO, each country, and also for the case of Portugal, we do have a very long list of pieces of heritage that are recognized with value at national, regional, or eventual municipal level. And then moving again to other level, we have all the rest of the heritage that constitute our cities, our built heritage, that needs preservation, needs conservation, needs attention. So, in fact, the problem of heritage is a complex problem. Allow me to say that since one of the main use of the buildings are the housing, please, we have to consider that there is an important concern in the world, which is the increase in the impressive increase of the prices of our houses, but also the renting prices are increasing a lot, at least in Portugal, as in many other countries in Europe. We are really we are close to a crisis. So this is something that has to be considered from the engineering perspective in order to look for solutions. And I'll come back to the problem later. In another direction, we have to recognize that in many countries in the world, we are still in a positive derivative tendency in the movement and immigration of population to the big cities, something that's also happening in Portugal. We're also assisting to a concentration of people in our larger cities. This is something that is a big concern where the engineering should find solutions. And so saying that around this problem of housing, for sure, that part of the problem can be, I will not say eliminated, but reduced, attenuated, adapting our existing buildings. So is why we should consider more and more serious the conservation and the rehabilitation of our heritage. We have to recognize that at least in Europe, in the last 25 years, we had an enormous increase of the investment in rehabilitation, in particular the rehabilitation of heritage. So say that, from what I said before, it is also important to highlight that we should not stop this movement. We should, in fact, keep the investment in the rehabilitation of our heritage, and also not just the special heritage, but also the common heritage. In another direction, I'd like to say that in many countries in Europe and also in Portugal, you are in a positive derivative of the growth cultural tourism that is pressing our cities, is pressing our heritage. So something that should be considered in all the policies of conservation and preservation of our heritage. In fact, in Europe, we have a very good set of examples of initiatives financed or incentivized by the European Commission in order to promote the rehabilitation of our building, both from the historical and heritage perspective, but also intending to improve their performance in terms of energy, as well as in terms of thermal comfort. We had eventually not in the same measure, but you have in Europe also some initiatives that incentivize the improvement of the safety of our heritage. I do believe, and there are very interesting movements in Europe that try to promote a renovation of heritage, provoking an equilibrium between the energy efficiency and thermal comfort, as well as the structural safety, particularly in all regards the seismic safety. And I truly believe that you should go in this direction, you should try to avoid eventual programs, eventual initiatives that will promote only energy improvement, energy performance improvement. Allow me please to refer here an example. This is the case of Italy, for which with different initiatives, there have been different programs that have promoted the private initiatives and also some public initiatives in order to improve the seismic capacity of the buildings and of all the heritage in generic terms, for example, based with tax incentives. But the interventions in heritage present a long list of challenges. Allow me please to highlight a couple of them. First, I have already referred the pressure of tourism. Second, the strong immigration movements that you are assisting all over the world, also in Europe. We should recognize that the society is nowadays more demanding in what regards the performance requirements that you say to our buildings. The codes that we have in support of engineering activity are more dedicated to new buildings. Of course, sometimes you adapt, we have some codes specifically dedicated to rehabilitation, but eventually they are not at the same level of detailing as the other codes we are using for new buildings. And then the costs associated to the rehabilitation, in fact, they tend to be higher in some situations that have to be considered. Another problem with assisting in many regions of the world is the shortage in terms of skilled labor workmanship, and also some experts in some expertise fields. In fact, for example, in civil engineering, we are really assisting to a moment in which the demand from society is not at the same level than the number of civil engineers that are educated in our faculty, something that society should look with rigor in the future. And then another very important problem is the knowledge. I should recognize that there are many situations you are doing the intervention in the heritage with the proper level of knowledge of the building you are intervening, with the proper knowledge of the problems, with the proper knowledge of the safety levels that we intend. But in many situations we are doing interventions eventually with not an adequate level of knowledge. We'll come back to this point later on. Scientific community all over the world, but also in Europe, has given an increased attention to the problem of heritage and on the problem of the conservation and restoration of buildings. This is shown by numbers, for example, by the publication numbers. But please, I have to refer that we as academics should put our effort in order to simplify the results of our scientific outputs in order to make them available and useful to the society. The society, the enterprises, the owners, and the urban planners that really need our research output, but simplified and oriented towards the real interventions. So, in what regards natural disasters, please allow me to refer here a couple of numbers and a couple of facts. In fact, we have to start recognizing that the number of natural disasters with important impact in our built heritage keep increasing. Of course, the earthquakes, which belongs to the geophysical events, are not the more frequent events. But looking at this plot, we can see that the economical impact of those natural disasters with important impact on our built heritage keep increasing and keep in an exponential manner. In fact, the natural disasters are more frequent than they used to be in the past, and they are costing us much more. Our built heritage environment is more complex, has more value associated, and so we should be prepared for the future. In another direction, we have to see that here in this plot that in the years that you have one or more strong earthquakes, we manifest a peak, because in fact, among all the important natural disasters that affect our built heritage, earthquakes, when they happen, they tend to affect larger areas, and they put to proof larger number of buildings and infrastructures. Among the natural man-made disasters that are affecting us, please allow us and our built heritage, allow me to refer the earthquakes. Here are some numbers. We recalled every year, in particular these last years, we had severe earthquakes in different regions of the world that causes an important number of fatalities, people affected, and important economic losses. But of course, storms, windstorms, they are very frequent, particularly in some parts of the world. The floods, please allow me to say that in Europe, in the last 4 decades, had experienced larger economic losses due to floods than other regions in the world that are recognized by this source of hazard. In what regards the wildfires, let's just say that we are recognizing that in some parts of Europe and also in Portugal, the wildfires are starting early in the year and they are lasting for longer periods, something that is really a big concern, because in some cases they are also affecting built areas. Fires, we all recall this important fire that destroyed parts of the Notre Dame Cathedral. We had also in Portugal in the 80s, at the end of the 80s, a very important urban fire that destroyed part of our city, of our capital. In 2015, we can refer as an example the big earthquake that affected the Kathmandu Valley in Nepal. We also remember well the current flooding that affects Venice in Italy. So some heavy rains that are affecting Machu Picchu, Peru, but also some other areas around the world. So climate changes, in fact, are affecting more regularly our built heritage, something that you have to consider. In regions where the urban expansion put pressure on our heritage, but also where eventually you have unregulated construction, these are other vectors that put an enormous pressure on our built environment regions. War and conflicts are also putting pressure, so we do hope, as example, I can refer the crisis in Syria and Bosnia-Herzegovina, and we know all very well the crisis you are living in Europe. We hope that this will soon be overpasses the problem, but again, the war and conflicts are affecting our built heritage, not just buildings, but something that you have to consider. Vandalism, pollution, especially in some parts of the world, it's something that is also affecting our communities, but particularly also our heritage. Tourism overload, something that is very important in some monuments, but also in some regions, particularly in Porto City, for example. Nowadays, we are living this experience. In fact, the overload pressure coming from tourism is putting pressure in the city center, in our built heritage, and something that has to be considered. It has to be solved from engineering perspective. Aging, of course, and then eventually some legal failures or some improper policies in the built heritage conservation. They may compromise the future of these important heritage that you have heredited and that you intend that you would like to be passed to the future generations. So allow me please to revise the concept of risk. We are all familiar with this concept, but it's always important to come back. Risk is influenced by 3 main pillars, 3 main vectors: hazard, vulnerability, and exposure. The hazard is, for example, redefining the hazard in terms of the source of hazard coming from the seismic activity, but we could also, of course, redefine this concept for different and for other types of hazard. But for the seismic hazard, hazard can be defined as the probability of a certain seismic action to occur in a certain place with a certain characteristics and for a certain period of time. So we know that you are monitoring continuously all the globe. So we know much more nowadays than you used to know in the past in what regards the seismic hazard. But of course, you cannot predict when will happen the next earthquake and how it will affect our heritage. In Portugal, those are the main source of hazard that may affect our built heritage. And among of them, please allow me to highlight the earthquakes and associated tsunamis. But of course, in the country, due to our location, especially due to the location of our main cities, we may be affected also tremendously by coastal erosion and by floods. It would be incorrect to talk about earthquakes in Portugal without referring to the big earthquake that you had in the mid of the 18th century that changed the history of Portugal and also has some important influence in the history of the world. It is recognized as one of the most destructive natural disasters in European history. And another pillar that affects the risk is the vulnerability. And the vulnerability, if you allow me to define in a very simplified manner, is the capacity that the buildings or the building infrastructure have to respond in safe to a certain level of demand. And then the exposure. The exposure is the third pillar that's related with the number of people that use the building of the infrastructure, eventually also related with the economic and cultural value of the goods associated to the building. So at the end, saying that, in fact, recognizing that risk is influenced by those three vectors, we are talking about new buildings, new infrastructure of new city. Of course, from the engineering perspective, we can manage the risk influencing those three vectors. But talking about heritage, we recognize that cannot. Our capacity is limited. We should put all our effort in order to reduce the vulnerability of the existing heritage in order to reduce the risk. In this final slide, on this part of my presentation, I'd like to highlight that great part of the heritage cities, great part of our oldest and more important heritage is located in areas with moderate to high seismic hazard. So talking about conservation of these heritage should be done always considering the eventual seismic activity and seismic hazard. Very briefly, allow me to revise the more common cause of collapse or poor behavior of our existing buildings. Let's start with older constructions made of masonry, eventually some timber elements in at the roof and floors. So before the introduction of reinforced concrete in the construction of current buildings, we had done all over the world construction based on those natural materials. We do recognize from the experience you have from research, but also from all that you have observed and you keep observing in the regions affected by earthquakes, we do know that our masonry, when they are poor in terms of quality of or when the state of conservation is also poor, the performance of our buildings or of our infrastructures may be affected. We do know that those type of typical masons, they have normally a very high stiffness. They attract large amounts of force, but they have a weakness associated. The capacity in plan of these masonries is limited. And when they collapse in a fragile manner. Also, depending on the geometry of the buildings or our infrastructures and depending on the way the different components of the buildings are connected among them, they may explore, in some situations, vulnerable collapse out of plane, something that it is quite studied in different universities in Europe. Critical points has building corners, openings, tend to concentrate the demands, and so these are points where the damage can be started. In aggregates, in urban areas, the interaction between buildings in some cases may save our buildings, in other cases may eventually promote the collapse or the poor behavior. And then finally, we have to consider that in some cases where you do interventions on buildings using inadequate materials, inadequate solutions, eventually you may increase the vulnerability of those type of old structures. Moving now to reinforced concrete buildings, we do know also from all that we have been observing, visiting areas affected by earthquakes, but also from all the results of our research all over the world, we know what are the weaknesses or where are the potential weaknesses of our building structural elements. Of course, the detailing of stirrups, the details of the anchorage splices, the joints being column joints or the connections between walls and slabs, something that has to be proper designed, proper detailed in order to promote the proper behavior. But then we have the well-known mechanism has strong beam weak column, especially in older buildings that were designed mainly for vertical loads or for very low lateral demands. They may present these mechanisms that tend to provoke a premature collapse of these buildings. The short column mechanism, the irregularity, something that I will come back later. And again, the interaction between buildings and urban areas, something these are problems that may affect the capacity and at the end of the day, the safety of our buildings. The in-plan capacity of the non-structural elements, in this case of our infill masonry, of course, we know again that these type of fill masonry, they may be very rigid, very stiff, but they have associated fragilities because in fact, they have a limited capacity and they tend to behave in a fragile manner. The out-of-plane collapse, something that I will come to the point later, but something that is also recognized as a potential fragility of our reinforced concrete buildings. From statistics, we may find in the literature different authors presenting and discussing these numbers, but please allow me to say that a great part of our built heritage, of our modern built heritage in reinforced concrete was designed and constructed in a period in which the codes were not at the same level of development as the actual codes. So an important part of our built heritage was designed previous to the modern codes, or eventually with the first versions of our national codes that were not as rigor and not as detailed as the ones that we are using nowadays in the design of new buildings. From recent earthquakes, and we have learned messages, and you keep learning messages every time that an earthquake affects our built heritage area. Please allow me to refer the city of BAM that was practically totally destroyed during the earthquake in 2003, that destroyed practically all the city of BAM in Iran. Another example, just to refer some examples, in Peru, 2007, this big earthquake, for example, in the city of Pisco, the majority, about 8% of the buildings collapsed or suffered irreparable damage. I'm talking about houses, but also some churches and other types of important heritage. But also keeping the attention to Peru, 2014, a moderate earthquake of magnitude 4.9 affected particularly Misca, and also again here, almost all the adobe constructions were damaged, including some churches. So this means that, in fact, many of our existing heritage, especially in the oldest ones with poor materials, they are in fact, we have to recognize vulnerable. So we have to keep attention to it and to prepare and to suggest that future policies should consider this fact. Central Mexico, 2017, among the buildings that collapsed or experienced poor behavior. Of course, the same causes are identified: poor material, detailing, flat slabs, something which is a big concern for us nowadays, and irregularities. If you compare what happened in the big earthquake of Mexico, 1985, this was at that time one of the causes that was appointed as a justification for the poor behavior of many buildings. 2017, 30 years after, irregularities keep to be one of the main important problems, especially in building corners in these recent earthquakes in Mexico that affected Mexico City, as you can see in this video. So the non-regular distribution of infills in plan as well as in elevation end up to promoting an irregular response, an irregular distribution of the damage, and eventually promoting the collapse and poor behavior of some buildings.
Professor Humberto, I'm sorry, 5 minutes.
Wonderful. Okay, so in the recent earthquakes we have studied in Southern Europe, we have seen we have extracted important messages, among them the out-of-plane collapse of this envelope components of our buildings. This is something that's really a big concern. So something that you have to look more in the future. And again, in Lorca, 2011, one of the causes that were associated to the poor behavior of many buildings was again associated to the irregularity, especially for buildings eventually that are regular structural systems with irregular distribution of infills. From the numbers and summing up the impact of the recent earthquakes in the last 25 years in the southern of Europe, we have seen that consider both affected people in terms of life, in terms of homeless, but also considering the economic losses. In fact, those numbers keep increasing. We should do our effort in order to put the engineering, the civil engineering knowledge in the response to this problem, okay, in order to prepare better our buildings, to prepare better our heritage. From all that you have seen in these last decades, we should recognize in a simple manner that most of the problems are located in older buildings that tend to be more vulnerable. But be careful, because new buildings designed with new codes, if you are not putting the proper attention to problem has the irregularities as well as the influence of the non-infill masonry, eventually you are introducing in our build heritage new buildings with new types of vulnerabilities. In what regards retrofitting approaches and solutions, so in fact we do have many solutions, but please, we do know that in the decision of an eventual strategy to be adopted in the rehabilitation or retrofitting of a building or of a set of buildings, we should consider a long list of parameters. But please allow me to detach one: knowledge. In fact, we do have more and more examples of good interventions with rigorous approaches, adopting the proper materials with a proper analysis. We do have that you are preparing better and better our professionals to approach this problem. Our companies are also getting new skills, and they are getting more and more prepared to approach this problem. But we should highlight that, in fact, in any intervention, in any decision, we should take the decision based on the proper level of knowledge. As Tiago referred in his introduction, in fact, you have a long set of tools that may support us from inspection until the intervention. We have new tools that are becoming more and more commonly used in the characterization of our buildings, in the characterization of the pathology. We should use them, and in fact the numbers highlight that this is happening. In fact, we do have in our laboratories, we do have in our universities, but also many companies are getting new skills and new capacities in order to test properly the materials as well as the structural systems. In terms of what regards modeling, we have powerful models that are used more and more in the characterization of a build heritage building that allow us to take a more rigorous decision at the time that you are proposing some solution. But those models need calibration. You should consider that among from the test, apart from the test characterization, we also have to use, and you have this potential to use monitoring. Also something that will be the central speech of Professor Ilara. But something that I have to recognize, even though we have these powerful tools, they are still underused. You have to reinforce more and more the use of this strategy in order to better understand the behavior of our buildings as well as of our infrastructure. In fact, those tools give us an enormous opportunity to do better our job, to prepare better the intervention of rehabilitation. But we should never disregard the contribution of the engineering as well as the other professionals in controlling all the process from the inspection until passing to the phase of design, but also in controlling the intervention. So those tools will be an enormous help supporting all the interventions, but the engineering contribution should always command all the process. To conclude, just to say that to define policies for the retrofitting or for the rehabilitation of a built heritage, we should understand properly how the structural systems evolved during times in our in the adoption, in the construction of the buildings, but also the non-structural materials and solutions, how much and how we have introduced the changes during time, because the different buildings that you have from different epochs may present different characteristics, and so any decision should be based on the proper knowledge on that. Allow me please to say that from our experience, what you see in the detail that is followed in the design, detailing, and construction from the structural elements is not at the same level than the rigor that is posed in the detail and construction of non-structural elements, something that has to be looked at in the future. One brief comment about costs. The structure itself in a current building costs less than 1/3 of the total cost of the total construction cost of the building. And the tendency is to be reduced. So there is no decay, this is not the case when you intend to reduce costs associated to our construction. This is not in the structural system. Precast. In many regions of the world, due to the crisis in housing, but also particularly in Portugal, we are assisting to an important introduction of or reintroduction of the precast systems and solutions in the construction of our buildings. We should not leave our industry alone. We should put our universities, our expertise in support to those companies in order to better in order to develop the solutions that should, as I will say, respond to the safety that are our basic requirements in our constructions. Buildings. We know and you recognize that due to the over-regulation of the construction sector, we do have enormous pressure in the decisions you are taking in our buildings to accommodate a long list of requirements. All of them are very important, but any solution that you adopt both in an existing building, but also in the retrofitting of in a new building, but also in the retrofitting of an existing building, we should recommend solutions that, of course, should respect that long list of requirements, but should not introduce new vulnerabilities. Talking about heritage, the challenge is huge. We should be prepared. Budget will always be limited, but from engineering perspective, if with engineering tools, we'll be able to embrace this problem. Solutions, as requested by Tiago. First, we need at the national and regional levels, we need strategic planning for retrofitting of and conservation of our heritage. We need to use more and more the partnerships between universities and laboratories and society, designers, constructors, and building owners. We have to increase the investment of new technologies. We have to produce standards and recommendations adequate for the rehabilitation. We have to insist in the development of professional training from workmanship to the more skilled engineers. And you have also to raise the public awareness about this big problem and this big challenge, which is our heritage. With that, I conclude. Thank you for your attention. Tiago, I give the word back to you. And sorry, because it took some extra minutes that were not planned. But please, Tiago.
Not at all. Thank you so much, Professor Humberto, for the inspiring presentation. We really appreciate. So as I said in the beginning, and also Laura said, so the Q&A are in the end. So we are moving to our next speaker, Professor Ilaria Venanzi. And Professor Ilaria Venanzi's presentation is titled Intelligent Damage Diagnostics and Structural Risk Assessment for Existing Assets using SHM Data. So Professor Ilaria, thank you so much again, and the floor is yours. Thank you.
Thank you very much. Good afternoon, everyone. First of all, I would like to thank the MDPI building team for the excellent organization, and a special thank to Professor Ferreira for the kind invitation and the warm introduction. So my talk, I hope you can see properly the screen. I think so, yes. My talk will be about damage diagnostics of structures using SHM data with both machine learning based and Bayesian based approaches. So what is SHM? SHM is the process of using sensors, data acquisition systems, and analytical techniques to assess the condition of a structure in real time. It involves the collection of data, such as acceleration, displacement, strain, temperature, to detect changes that may indicate damage. SHM presents many advantages in the context of safety assessment, as it allows uncertainty reduction, early stage damage detection, and it supports condition-based maintenance and decision-making. SHM involves several stages, from the simplest to the most complex. Stage 1 in particular regards detection, damage detection, and answers to the question, is the structure damaged or not? The following two stages regard localization and quantification, and respond to the questions, where is the damage area located and what is the extent of damage? The final stage is damage prediction that answers to the question, what is the remaining service life of a structure? Analytical techniques to perform these tasks can be classified into data-driven and model-based approaches. Data-driven approach relies on sensor data and uses a statistical algorithm or machine learning to learn patterns that distinguish healthy and damaged states. Conversely, model-based approach use physics-based analytical or numerical models, and the damage detection is performed by comparing the structure's measured behavior to the predicted one exploiting the model. Data-driven approaches mainly can answer the first question. They can be used for anomaly detection, while to assess damage location, quantification, and classification, very often we need to refer to model-based approaches. If the task is damage classification and tracking of damage evolution over time, as I said, we need to refer to a model-based approach. So we need to calibrate a high-fidelity finite element model using all the available information, original structural design information, non-destructive evaluation, and structural health monitoring data to calibrate this model. This model constitutes a relationship between input and output parameters. Input parameters are damage-sensitive parameters, like those related to stiffness on the different parts of the structure, and output parameters are response parameters that we can obtain from a structural health monitoring system. To reduce the computational effort, which is inherent in the use of this sometimes very complex finite element models, we can adopt surrogate modeling. Surrogate or meta models are mathematical relationships obtained, for example, with the neural networks, analytical models, 3D models, that we establish between the input and the output parameters. Either if we use finite element models or surrogate models representing this input-output relationship, to obtain damage assessment, we must solve an inverse problem. An inverse problem starts from observations, that is structural health monitoring data, and tries to extract information about damage. So, to solve this inverse problem, we can exploit different approaches. We can use deterministic methods that formulate the inverse problem as an optimization problem and tries to minimize a cost function that measures the discrepancy between measured and simulated response. Or we can use Bayesian approaches that frame the inverse problem as a probabilistic inference problem. Finally, we can use machine learning-based methods that solve the inverse problem by learning directly from SHM data without or with a minimal explicit physical modeling. So based on this, in the following of this presentation, I will illustrate 4 different approaches developed by our group, which share the general objective of detecting or classifying damage in various types of structures using different approaches. The first one I will present you regards a Bayesian model updating and data fusion approach for damage classification. The second one, a machine learning based method for anomaly detection in mesoarray structures. The third one regards the use of Bayesian neural networks for probabilistic damage assessment. And finally, I will give you some hints on what is transfer learning, with the purpose of sharing information at the network scale among different structures to improve SHM-based damage detection. Let's start with the first approach. The case study to which we will refer is the Consoli Palace, which is a medieval building located in Umbria, my region, and in particular in a city called Gubbio. In this building, a continuous monitoring system was installed in 2017 by our research group, and the current SHM system, which has been improved in time, consists in 12 accelerometers for linear variable transducers and 6 thermocouples. Then in May 2021, ambient vibration tests were carried out using additional several accelerometers to adequately capture the dynamic behavior of the building and also of the bell tower that showed an independent, likely different behavior that had to be double-checked. The ambient vibration tests made it possible to identify the main vibration modes of the building and calibrate a high fidelity finite element model developed in Abacus. The proposed methodology consists in an offline and an online one. The offline is shown at the top. After the calibration of the finite element model, the key step was the definition of damage-sensitive parts of the structure, identifying possible damage scenarios. This was done based on engineering judgment, because some parts of the structure presented specific behavior and potentially could experience local mechanisms. And in addition, we performed pushover analysis to identify some other damage scenarios and some other portions that could be affected by earthquake. Then a Kriging metamodel was calibrating, relating the elastic moduli of the different portions of the different damage-sensitive portions of the structure, that is the stiffness multipliers, to the model parameters obtained from the ambient vibration test. And on the bottom right, you can see the